8th grade greetings. Welcome to week 2 of your ISTEP tutorial. Big boy pants, put them on. This is a tougher one. There's a lot of areas where it tries to slip you up. So stay with me. This might be a little bit longer, but it'll be worth it. Here we go. Amy works in a sandwich shop. She prepares roast beef sandwiches using slices of roast beef from a container. The graph shows the relationship between the number of slices in the container, Y. They just told you what Y represents, by the way. Y represents slices in the container of roast beef. And the number of sandwiches made, oh, they just told me what X represents. Number of sandwiches made. Now, when you see something like this, I want you to understand what this is really representing. If you've been graphing it all, you kind of are used to looking at the X and the Y axis. Well, do you understand that this is a positive number, that's a positive number? So what quadrant would it all occur in? Well, we're literally only looking at this part of the graph. So I just want you to understand, that's going to help us. Because when we start looking at this graph, part A asks us, construct a function that models what we see on the graph, okay? Now, this is where you have to remember what you've been taught. They're talking about y equals mx plus b. This is going to help you a tremendous amount. If you're not familiar with this, you're going to learn a lot because this entire problem is based off this. M, what does M represent? Good, I think someone said it. This could be called slope or rate of change or rise over run. All of these represent M, okay? Those are different ways to say it. B represents the y-intercept or your initial. Oh, that looks terrible. This says initial, just trust me. Initial point, or where you start, okay? Now I'm going to use that to help me when I start creating a function. So to create a function or an equation, I need the y-intercept and I need the slope. So if this is really only representing this quadrant, then wherever it hits the y-axis is my y-intercept. So think about it. If it was going like this, where's my y-intercept for my line? Right there. So my y-intercept is 96. We'll talk later about what that means. The slope's a little trickier. When you're looking at a graph and trying to identify the slope, find what I call perfect points. Do you understand that right there, it's kind of in between two things? Right here, it's exactly where something crosses. And that pattern is consistent. So here's what a lot of students do. This is wrong, by the way. A lot of students go, okay, so for my slope, I know this, my teacher taught me, it's rise over run. So I'm going down 1 and right 2. And so students will come up with a slope of -1/2. Not bad, not bad. You at least understand something about this. But here's where you have to be careful. Did you look at the increments? Did you look at what it's counting by? If I go down 1 grid on the y-axis, do you understand that's really going down 8? So I'm really going down 8. And by the way, down represents negative. And if I go right 2, well, look at that. For every 2, oh, that really means I only went over 1. Do you see what I'm talking about? The units that we count by. So while I'm looking at squares, I go down 1 square and right 2 squares. That represents going down 8 and over 1. So my slope is -8. We'll get into what these mean here in a second because that's asked later. But that is how I am going to create my function. I identified that my graph starts, my initial, or where x is 0, y is 96. And if I continue this pattern, I'm always going down 8 and over 1. I'm going to use this to create my function. It's going to go away here in 3, 2, 1, go. And my function is y equals -8x plus 96. That took the place of b, which was my y-intercept. That took the place of m, which was my rate of change. Now, what does that mean? What does that mean, okay? So when I see a slope of -8 here representing this, think about it. As we went from 0 to one sandwich, we went down 8 on the y, which is slices. So every sandwich, I lose 8 slices. So we could say that, or probably if we're just being very honest, what does the slope represent? Each sandwich has 8 slices of roast beef. That's really what my slope is telling me. Now again, you can say that in a variety of ways. You can say we lose 8 slices for every sandwich we make. That's the same thing. Okay? Anything that equates 8 slices to a sandwich will work for your slope. And the y-intercept. Remember we circled and drew an arrow at the very, very top? What was y representing? The number of slices. Okay, so the y-intercept. How many sandwiches have you made at the y-intercept? None. So the y-intercept tells me that each container starts with, oh, come on, bam. Didn't work this time. Okay. 96 slices of roast beef. That's what this function's telling me when it refers to the graph. I lose 8 slices per sandwich, but a container starts with 96 slices. Okay? We're only halfway done. But now we get to use some of this information. Part of it was the creation of it and understanding and interpreting graphs. That's a big thing they test in the ISTEP. But now let's see how they want us to use it. All right, I'm going to get rid of this. When I scroll, what are they asking me next? Oh, my own table. In the table, record the number of slices of roast beef remaining in the container after the given number of sandwiches are made. There's a lot of ways to do this. But I'm going to use the mathematical approach. If I already stated that y is found by taking -8 times x and then adding 96, right, that was our equation. Number of sandwiches made. Do you remember this is representing the x? Slices left, that's representing the y. So to find these answers, I'm essentially taking y equals -8 times my x value, 4, plus 96. Then you see this is going to be replaced with 6. This is going to be replaced with 8. This is going to be replaced with 10. It's an easy way to find it. And just multiply by -8, add 96. Multiply by -8, add 96. Because this function is consistent for every single number of sandwiches I throw at it. Now, here's what probably most of you did. You find that first one, right? Find that first one. If it's 4 sandwiches, that means 4 times -8, so there's -32 plus 96. We come up with 64, okay? Now you can plug into the formula 3 more times, and by the way, that's about the same amount of time as what I'm going to show you. Most students do this. Well, I went up 2 sandwiches, so I'll subtract 16 every time. That works. If you haven't noticed, that works. Because if we lose 8 every sandwich, we lose 16 every 2 sandwiches. Doesn't matter how you come up with it, okay? So if I fill it in, I'll get a 48, 32, 16. Make sense? So how do we find this? One, you can plug and chug if you want, or you can use the equation we created to find out every single one. All right. Part D, almost done. Almost done. Oh, come on, stylist. Don't fail me now. The selling price of a roast beef sandwich is $7. How much money has the shop collected from the sale of roast beef sandwiches when the container is empty? Okay? Container empty. Now keep in mind, the container was represented by Y, and the number of sandwiches was X, right? This is what we need to know when we approach our function again. Because how many sandwiches can I make with a container? This is where we use our function. If you're telling me the container's empty, then that means I have 0 slices left, right? If I am empty, I have no more slices in the container, that means I have 0 slices left. Well, how many sandwiches is that? I don't know. So now I can solve for x to find out, hey, how many sandwiches does it take to empty the actual container? From here we solve, we start the isolation process. Whatever's being done to x, we do the opposite. So if I'm adding 96, I subtract it. And if x is being multiplied by -8, I divide by it. And we got a final answer of 12. Now, you may be thinking, why are you doing this? They asked us how much money we're going to have. Okay, but if it's $7 per sandwich, I need to know how many sandwiches I sold. Now I know, after selling 12 sandwiches, the container's empty. So now I can decide how much money that would cost. If I sold 12 sandwiches to empty the container, and each sandwich is $7, I know that I'll have a total of $84. How'd you do? Not only was that one slightly difficult, it took a while. So be prepared for some of those problems. Not only is it going to be challenging mentally to actually do the academic side, but it's also going to challenge you mentally and attention span wise to stay locked and loaded for a while. You got to stay in that actual thinking mode for all the different parts. Did you show your work? You better. Did you use the equation, or did you guess and check your way through? Which, by the way, you might have been able to play around with numbers, but here's the problem. If you're playing around with numbers, you got to show how you came up with your answers. Most of the students I had that played with numbers just did stuff in their head and worked on scrap and then just put a final answer. If you just give the answer, you're just getting half the points, okay? Excellent job. Keep working, keep learning. Have a wonderful day.